All right, we're going to look at some quadratic equations for solving trig equations. This is the second part of my 5.4 video. We're going to go over three examples, okay? So let's take a look at A. Now, I know that this is a quadratic because there's this little squared here, okay? And it's starting to look like a trinomial. So here is one term that's being squared, here's another term, and then the third term is my constant, the one that has no variable. Okay, now if you look back at the beginning of the 5.4 video, the last one, you'll see that we actually broke down a trinomial using a grade 10 method, which is just factoring. Okay, so what I would do is take a look at this very first term and say, okay, well, how do I break that down? Well, I need two sines to be able to multiply together to give me the sine squared. I also have to make a 2, so 2 times this invisible 1 will give me that 2. So 2 sine times a sine gives you 2 sine squared. All right, that means that those are the first terms in each of the brackets. Now, how do I get the back of each of the brackets? Well, these two backs have to make up this last constant number. All right, so what two numbers multiply to -1? Well, it's only -1 and +1. How did I know though that these weren't switched around, like that -1 didn't go here and the +1 didn't go here? I always do this kind of a guess and check method. So this is my guess and I'm just going to check it now. I'm going to check that when I take the outside two, so these two, and I multiply them, and I put that together with the inside two multiplied together, that they make this guy. So this is my checking. All right, so when you're doing expanding or FOIL, all right, this guy times this one should equal this. Your outside would make 2 sine, and then your inside makes -1 sine, which adds together to give you that positive 1 sine. And then your last one would be to take the blues and multiply them together, and then you get this guy right here. Okay, so my checking means that I've done it correctly. Now I have this equals to 0 on one side so that I can solve each of the brackets now. All right, so I want to make sure that I figure out what this side equals to when it equals to 0, and then what x equals to over here if I make it equal to 0 as well. All right, now you're just going to solve so that I have sine x by itself. So bring the -1 over to the other side, and I get a +1. Then I'm going to divide out that 2, and I get sine x equals to 1/2. All right, if I want to start to solve for x on that side, I'm going to get certain answers. So sine x is equal to +1/2 in these two quadrants. Okay, and I've completed the triangles with the special triangles, so I know that each of the angles are pi/6. And then since we're only talking about a domain of 0 to 2 pi, that is one rotation. All right, so we get two answers. That is going to the first terminal arm, which is pi/6, and the second terminal arm I calculated by going all the way to pi and then going backwards pi/6. So that is 5 pi/6. All right, now let's take a look at our other one. Move the 1 to the other side, it becomes a -1. And then I'm going to solve. Now this one is a little bit different. I recognize that 1 and 2 are part of the special triangles, but -1, I don't really know if that's part of a special triangle. Like neither of the special triangles come to mind. So what I'm going to do instead is I think I know when sine is equal to -1 through the graph. Okay, so what I did is I just made a quick sketch of the sine graph, and isn't this at a height of -1? Well, when does that happen? What is the x value here? Well, that's one of the 5 major points of a sine graph, and we already know that that is at 3/2 pi. All right, so I'm going to put the blue answers and the red answer together. All of my answers together satisfy this equation. Okay, so this this question has 3 different answers to it. Let's try another one. Okay, so here's B. If you take a look closely, we actually have two terms here. So it's not a trinomial like the previous example. It looks like we have a binomial, and they do have something in common. They each have a sine. All right, so what I'm going to do is I'm going to factor out that sign and I'm going to put the rest into a bracket. So from this term, if I take out that blue part, I have 2 and cos x left over, so I'm going to write that right there. From this term, if I divide out that sine x divided by sine x is going to give me a positive 1. So I've common factored here, and now I'm going to solve each of those parts. So I want to know when this is equal to 0 and when this is equal to 0. All right, so this one, I mean, we can't really do anything else with it because sine is already by itself on one side. We want to make sure that this guy has the cos by itself. Bring the 1 to the other side, it becomes a negative 1. And then let's divide out that 2. So I got cos x is equal to negative 1/2. So solving each one separately, what I'm going to do is I'm just going to tackle this one. Like I said, sine equals to 0. Now I don't know any special triangles that have a 0 in it, so I'm just going to look at the regular sine graph, and there are 3 positions where it equals to 0. That's at 0, pi, and 2 pi. This is one part of my answer. Now we're going to solve this part. Now 1 and 2, okay, those are numbers that I recognize from the special triangle, so I'm going to draw out the special triangles where cos is negative. And that's in the second and the third quadrants with a pi over 3 as my angle. Okay, so what I'm going to do is, since we're talking about this domain, we're going to go from 0 to 2 pi, and those are these two answers. That's all the way to pi and then subtract a third, so that's 2/3 pi. And then all the way past pi and an additional third, which means 4 pi over 3. So I have 5 answers here. I have all of my green answers and all of my blue answers that fit within this domain. All right, now the last example, oh geez, okay, so now we're talking about tan here. Well, that shouldn't make things that much more complicated. Let's just begin like we normally would. Okay, now I want a 0 over here so that I can start factoring. I'm going to bring this tan to the other side first. Okay, that makes a negative tan. And now I'm noticing that I have one term and another term. Both terms seem to have something in common. Okay, these tans look like they're in common, so I'm just going to common factor it out and then put whatever the leftovers are in this bracket. So from the first term, if I divide out a tan, I'm going to be left with cos squared. From this guy over here, if I divide this guy by tan, I'm going to get a 1, and that negative stays the same. Now I'm going to solve both of the parts. So what is x when tan x equals to 0, and what is x when cos squared x minus 1 equals to 0? This is pretty much solved as much as it could be. Tan x is by itself. This one, maybe we can go a little bit further. Let's bring the 1 over to the other side. It becomes a positive. Then we're going to get rid of that squared by square rooting. Okay, so here's a little bit of a trick. When you square root something, remember that you get a positive and negative answer. If you only put the square root of 1 is 1, you're going to be missing some answers. Okay, so you won't get full marks. All right, this is probably the easier one to deal with because tan, I don't really remember what it looks like. We'll deal with that later. I do know what cos looks like. Cos looks like this guy right here within a domain of 2 pi, which is what we're looking at. Okay, and it is positive 1 at this placement and this placement. So 0 and 2 pi. That's in red. Now, where is it negative 1? It's negative 1 right down here, and that happens at pi. So cos squared x minus 1 equals to 0 has these 3 solutions. All right, let's look at this guy. Now we got to remember what tan x looks like. Okay, so there it is right there. It's a really weird one with asymptotes. And where does it equal to 0? Well, it looks like it equals to 0 at these 3 placements. So we have 1, 2, 3 answers, okay, for this guy. Now I have 6 different sort of colored answers. Why do I only have a final answer of 3? And that's because, well, they're just overlaps of each other. See, 0 pi and 2 pi, 0 pi and 2 pi. So my final answer is 0 pi and 2 pi. All right, so again, you're going to have to take any knowledge that you know about factoring and any knowledge that you know about quadrants, plus any of the graphing knowledge and put it all together, and that's what you're going to need to know to solve any of these trig equations.